Ali puts these 5 numbers in their correct places on a number line. We need to write the number closest to 500 and write the number furthest from 500. So let's find the difference for these numbers. 511 is 11 more than 500. 499 is 1 less. 502 is 2 more. 555 is 55 more than 500. And 455 is 45 less, because if we subtract 455 from 500, we'll get 45. Or if we add 45 to 455, that will give us 500. So the number closest will be the number with the smallest difference. So that's 499, because that only has a difference of 1. And the number furthest will be the number with the largest difference. So that's 555, because that has a difference of 55. Put these houses in order of price, starting with the lowest price. 1 has been done for you. So we have 135,300, 119,125, 130,500, 131,500, and 91,500. So we can see that the lowest price is £91,500, because that number only has 5 digits, but all of our other numbers are 6-digit numbers. And if we're comparing whole numbers, a number with fewer digits will be smaller. So that means the lowest price is house E. Then the next lowest is house B, because we can see that all of the houses that we have left have 1 in the 100,000s, but house B also only has 1 in the 10,000s, and all of our other numbers have 3 as the 10,000s digit. So now the houses that we're left with all have 1 in the 100,000s and 3 in the 10,000s. So we need to look at the thousands digits. We have 5, 0 and 1. So this number with 0 in the thousands will be next, and that's house C. So that's 130,500. Then we'll have 131,500, so that's house D. And then our highest value house, or the house with the highest price, will be house A, because that's 135,300. So the 5 in the thousands tells us that it will be more expensive than houses C or D. Write the 3 missing digits to make this addition correct. So the way to solve missing digit addition problems is to follow the same steps that we use for column addition. So here that's starting with our ones column. We have something plus 4 is 5, so this missing digit here must be a 1, because 5 minus 4 is 1, so 1 plus 4 is 5. And now we can move on to our tens column. We have 5 plus something, but we have a 1 as the tens digit of our answer. So clearly they haven't added to 5 to make 1. They must have added to make 11 and then carried the 1. And 5 plus 6 is 11, because 11 minus 5 is 6. So this missing digit here has to be a 6. And now onto our hundreds, we have 1 plus 1 plus 4, so that's 6. This table shows the number of people living in various towns in England. What is the total of the numbers of people living in Formby and Telford? So we can see that 166,640 live in Telford and 24,478 live in Formby. So if we want the total for both towns, we need to add. And when we use column addition, we get 191,118. Now, what is the difference between the numbers of people living in Bedford and Dover? So the difference is what we get when we subtract. Now we can see that 82,448 live in Bedford and 34,087 in Dover. So when we subtract using column subtraction, we get an answer 48,361. Write each number in its correct place on the diagram. So on the diagram, we have ovals for prime numbers, even numbers, and square numbers. So we can remember that a prime number is a number which only has two factors. It's only in the 1 times table and its own times table. An even number is a multiple of 2, so a number in the 2 times table, or a number that ends in 0, 2, 4, 6, or 8. And a square number is what we get when we multiply a number by itself. So first we have 16. That's an even number because it's in the 2 times table, it ends in a 6, and it's a square number because we get 16 by multiplying the number 4 by itself. 4 times 4 is 16, so 16 is a square number. It's not a prime number because it's not just in the 1 and 16 times table, but also in the 2 times table, the 8 times table, and the 4 times table. So we need to write 16 here, so that it's in the oval for even numbers and in the oval for square numbers. So where it overlaps, where the two ovals overlap, that will be the area for both. But it's not a prime number, so it's not in this oval here. Now 17 is a prime number because it's only in the 1 times table and the 17 times table. It's not an even number because it's not a multiple of 2, it ends in a 7, so it's an odd number, and it's not a square number. So we need to write 17 in this section here to show that it's only a prime number, not an even or square number. Now 18 is not a prime number because it's not only in the 1 and 18 times table, but also in the 2 and 9 times tables. It's an even number because it's a multiple of 2, but it's not a square number. You don't get 18 by multiplying a number by itself. So we need to write 18 in this section here. And now 19 is a prime number because it's only in the 1 and 19 times table. It's not an even number because it ends in a 9, so it's an odd number, it's not a multiple of 2, and it's not a square number. So 19 needs to be written in this section here as well. This diagram shows a shaded shape inside a border of squares. Draw the reflection of the shape in the mirror line. So we need to reflect the shape so that we have the same reflected on both sides, and the way to do that is to dot the corners. So we have 3 points here which are on the mirror line, so they'll be on the mirror line when we reflect the shape as well. This point here is 2 squares to the right, so from the mirror line we can go 2 to the left. This point is 4 to the right, so we can go 4 to the left. This point is on the end 2 down, so we can go 2 down from the end. This point here is in the corner, and this point here 1 before the corner. So now that we've dotted the points, we can connect them, and we've reflected our shape in the mirror line so that we have the same reflected on both sides. Write the 2 missing values to make these equivalent fractions correct. So we know that to find equivalent fractions, we use multiplication or division. Now 3 times 4 is 12, so we do the same to the numerator. So we can think what times 4 is 8. Well, 8 divided by 4 is 2, so 2 times 4 is 8. 2/3 is equivalent to 8/12. And now here we have a fraction which needs to have a numerator of 4. 8 divided by 2 is 4 because 4 times 2 is 8. So because we divided the numerator by 2, we need to do the same to the denominator, and 12 divided by 2 is 6. Circle two numbers that add together to equal 0.25. So our answer is 0.05 and 0.2, because if we add 2/10 and 5/100, we get an answer of 0.25, because that's 2 in our tenths and 5 in our hundredths. We know that when we're adding decimals, we line up the decimal points, so that's 0.2 and 0.05, and then we can write zeros in empty squares and copy down the decimal point. So 0.2 plus 0.05 gives us 0.25. Now lots of children, when I was marking this, wrote 0.23 and 0.2, thinking that you could add the 2/10 to the 3/100 to get 5/100. But if we have 0.23 plus 0.2, we need to line up the decimal points, and then that gives us 0.43, not 0.25. 6 pencils cost £1.68. 3 pencils and 1 rubber cost £1.09. What is the cost of 1 rubber? So if we know that 6 pencils cost £1.68, we can find the cost of 1 pencil by dividing by 6. So £1.68 divided by 6 is 28 pence. So we know that 1 pencil costs 28 pence, so we can find the cost of 3 pencils by multiplying 28 pence by 3. So that tells us that 3 pencils cost 84 pence. So 84 pence plus 1 rubber equals £1.09. So we can subtract 84 pence from £1.09, and that gives us 25 pence as the cost of 1 rubber. We could have also worked out the cost of 3 pencils by dividing £1.68 by 2, because 3 is half of 6, so we could have found half of £1.68 by dividing it by 2, rather than dividing by 6 and then multiplying by 3. But then, as soon as we know that 3 pencils cost 84 pence, we can find the cost of 1 rubber by finding the difference between 84 pence and £1.09. Each diagram below is divided into equal sections. Shade 3/4 of each diagram. So 3/4 is 3 parts out of 4. So because this first diagram has 4 pieces, we can shade any 3 of those pieces. But now this diagram here has 12 pieces, so we need to find an equivalent fraction to 3/4 with a denominator of 12. 4 times 3 is 12, and 3 times 3 is 9. So we need to shade 9 pieces of the 12 pieces of this diagram. And here we have 8 pieces altogether, so we need to find an equivalent fraction with a denominator of 8. 4 times 2 is 8, and 3 times 2 is 6. So to shade 3/4, we need to shade 6 of our 8 pieces. A packet contains 1.5 kilograms of oats. Every day, Maria uses 50 grams of oats to make porridge. How many days does the packet of oats last? So we know that 1 kilogram is 1,000 grams, so that means 1.5 or 1.5 kilograms, is 1,500 grams, because 1.5 times 1,000 is 1,500. Now we know that Maria uses 50 grams each day, and if she has 1,500 grams, we can find the number of days by dividing 1,500, so the total, by 50, which is the amount that she uses each day. Now remember, when we have division problems, if we have an end zero in both our dividend and our divisor, we can cancel the end zeros, and then 150 divided by 5 is 30, so the packet will last 30 days. The other way to divide 1,500 by 50 is to count up in steps of 50 until we get to 1,500. So we know that one day she will use 50 grams, and if we multiply by 2, that means in 2 days she uses 100 grams of oats. We can multiply that by 5, so 2 times 5 is 10, and 100 times 5 is 500. So in 10 days she uses 500 grams, and 500 times 3 will take us to 1,500, so take us to the total number of grams in the packet, and 10 times 3 is 30, so that means it takes her 30 days to use all 1,500 grams or 1.5 kilograms of oats. N equals 22. What is 2n plus 9? So 2n means 2 times n, so we need to work out 2 times 22 plus 9. 2 times 22 is 44, so 2n, 2 times n, is 44, and then 44 plus 9 is 53, so that's our answer. Now 2q plus 4 equals 100. Work out the value of q. So if we subtract 4 from 100, that's 96. So 2 times q, or 2q, must be 96, because 96 plus 4 is 100. But if 2 times q is 96, to work out q, we need to divide 96 by 2. We can use short division, and that gives us 48. So that's the value of q, because 2 times 48 plus 4 is 100. 2 times 48 is 96, and 96 plus 4 is 100. A stack of 20 identical boxes is 140 centimeters tall. Stefan takes 3 boxes off the top. How tall is the stack now? So if we know that 20 boxes has a height of 140 centimeters, we can find the height of one box by dividing 140 by 20. So because we have a division question with end zeros, we can cancel our end zeros, and then 14 divided by 2 is 7. So that tells us that each box has a height of 7 centimeters. Stefan has taken 3 boxes off the top, so that's 3 times 7, or 21 centimeters, that he's taken off. And if he started with 140 and took 21 off, we can work out 140 minus 21, so that's 119 centimeters left. The other way would be to work out that if he's taken 3 boxes off the top, he now has 17 boxes, because 20 minus 3 is 17. And if we know that each box is 7 centimeters, we can multiply 17, so the number of boxes he has left, by 7, and that will give us 119. Write all the common multiples of 3 and 8 that are less than 50. So a multiple of a number is in that number's times table, or it's a number that can be divided by that number without giving a remainder. So because we want the common multiples of 3 and 8, we need numbers that are in both the 3 and 8 times tables, or numbers that can be divided by both 3 and 8 without giving a remainder. So multiples of 8 are numbers in the 8 times table, and because we want numbers that are less than 50, we can stop at 48. So which of these numbers are also in the 3 times table? Well, 24 is a multiple of 3 because 8 times 3 is 24. And 48 is also in the 3 times table. 48 is a multiple of 3 because if we divide 48 by 3, we get 16. So that tells us that 16 times 3 is 48. So 48 is in the 3 times table as well as in the 8 times table, and so is 24. So the common multiples of 3 and 8 that are less than 50 are 24 and 48. They're numbers that are in both the 3 and the 8 times tables. This thermometer shows temperatures in both degrees Celsius and degrees Fahrenheit. Work out what 25 degrees Celsius is in degrees Fahrenheit. So we can see that we have degrees Celsius on this side and degrees Fahrenheit on this side. Now we need 25 degrees Celsius, so that will be right in the middle of 20 and 30. So to find the number of degrees Fahrenheit, we need to find the number that's right in the middle of 68 and 86. So to find the number halfway between 68 and 86, to find the midpoint of any two numbers, we can add them together and then divide the answer by 2. So 86 plus 68 is 154, and if we then divide that by 2, we get 77. So 25 degrees Celsius is the same as 77 degrees Fahrenheit. And that makes sense because 68 plus 9 is 77, and then 77 plus 9 is 68. So we have the same on both sides. The other way to work out the midpoint of 68 and 86 would be to imagine a number line. So 77 is right in the middle, and we could work that out by adding 5 to 68 and subtracting 5 from 86. Then we could spot that if we add 4 and subtract 4, we'll get the number in the middle, because we've added and subtracted the same from both sides. So that gives us a number right in the middle of 77. So that's 77 degrees Fahrenheit. Write the number that is 5 less than 10 million. So here we need to work out 10 million minus 5. We write 10 million with a 1 followed by 7 zeros, because if we remember our place values, we have our ones, tens, hundreds, our thousands, 10,000s, 100,000s, then our millions and 10 millions. So 10 million minus 5 is 9,999,995, because if we added 5 to that, we would have 5 plus 5, so 110, but we already have a 9 in our tens and a 9 in all of our other place values. So these 9s would change to zeros, and then we'd have 1 in front, so we'd have 10 million. But if this is confusing, remember you can just work out 10 million minus 5 with a very long column subtraction with lots of exchanging, and you'll get the same answer. Now write the number that is 100,000 less than 6 million. So here we need to work out 6 million minus 100,000. That's 5,900,000, because if we added 100,000 to that, we would have 10 100,000s, so that would make an extra million. But again, we can use column subtraction if we need to, and we get the same answer. Calculate the size of angles A and B. So we can work out the size of angle A because we can see that here we have straight lines crossing, and so we have vertically opposite angles, and vertically opposite angles are the same size. So here, because we have straight lines crossing, if we know that this angle is 160, then angle A will be 160 degrees as well. Now we can see that we have little squares in the corner here and here, and they show right angles which are 90-degree angles. So we know that angle A is 160, and we know that both of these angles are 90 degrees. So we can work out angle B by remembering that angles in a quadrilateral add up to 360 degrees. So a quadrilateral is a four-sided shape, and we have here a shape with four sides. So we can subtract 160, 90 and 90 from 360, and that will give us angle B. 90 plus 160 is 250, plus 90 is 340. So if we subtract 340 from 360, we get 20, so angle B is 20 degrees. Write the missing number. 70 divided by something equals 3.5. So we have a missing number division problem, and when it's the second number or the divisor that's missing, we still divide to find our missing number. So here we need to work out 70 divided by 3.5. So we need to work out our 3.5 times table. If we work out 3.5 plus 3.5, that will give us the answer to 2 times 3.5, because adding a number to itself is the same as multiplying it by 2. And that gives us 7.0. So 2 times 3.5 is 7, because if we have a 0.0 on the end, we have a whole number. So because 2 times 3.5 is 7, that means 7 divided by 3.5 is 2. And then 0 divided by 3.5 is of course 0, so our missing number is 20. 70 divided by 20 is 3.5. So if we know that 2 times 3.5 is 7, then we know that 20 times 3.5 must be 70, because if we have an end zero in a multiplication question, we need an end zero in our answer. But that tells us that 70 divided by 3.5 will be 20, or 70 divided by 20 will be 3.5, because if we have a multiplication, we can divide the answer by one of the numbers in the multiplication to get the other number. So 70 divided by 20 is 3.5, and then we could check that we'd got this right by working out 3.5 times 20. And if our answer is 70, then we have the correct number here. Miss Mills is making jam to sell at the school fair. Strawberries cost £7.50 per kilogram. Sugar costs 79 pence per kilogram. 10 glass jars cost £6.90. She uses 12 kilograms of strawberries and 10 kilograms of sugar to make 20 jars full of jam. Calculate the total cost to make 20 jars full of jam. So she uses 12 kilograms of strawberries and they cost £7.50 per kilogram. So to find how much she spent on strawberries, we can multiply £7.50 by 12, and that gives us £90. We also know that she used 10 kilograms of sugar, which is 79 pence per kilogram. So 79 pence times 10 is 790 pence, or £7.90. And she made 20 jars full of jam, but jars are £6.90 for 10, so if she needs 20 jars, that will be 2 lots of 10 jars, so 2 times £6.90, and that comes to £13.80. So to find the total cost, we need to add what she spent on strawberries, what she spent on sugar, and what she spent on glass jars. And £90 plus £7.90 plus £13.80 gives a total of £111.70. Here are two triangles drawn on coordinate axes. Triangle B is a reflection of triangle A in the x-axis. So this line here, the x-axis, is the line of reflection. Two of the new vertices of triangle B are 10 minus 10 and 20 minus 30. What are the coordinates of the third vertex of triangle B? So this point here will be 10 minus 10, because we can see if we go down from this point, or if we go up from this point, we have the same x-coordinate. So the x-coordinate stays the same, but the y-coordinate changes, because if we go across, we have a y-coordinate of 10 here, but if we go across from this point, we can see that our y-coordinate will be below 0. So that's minus 10, because the x-coordinate is the line of reflection. And here we'll have 20 minus 30. If we go down from this point, we get to here on the x-axis, and if we go up from this point, we get to the same point on the x-axis. So the x-coordinate stays the same, but then we have minus 30 as our y-coordinate, because here the y-coordinate was 30 above the x-axis, so above 0, but here the y-coordinate will be 30 below 0, so that's minus 30. And that means the x-coordinate for this point, so for the third vertex, will be minus 10, because if we go up from this point, we get to here on our x-axis, and that's the same point as if we go down from this point here. So that's an x-coordinate of minus 10, and then our y-coordinate will be minus 40. So for this point, we have a y-coordinate of 40, so 40 more than 0, but because we're reflecting the triangle in the x-axis, this point here, so the y-coordinate of this point here, will be 40 below 0, so that's minus 10 minus 40 as the coordinates of the third vertex of triangle B.